Hello, I am Tate, and I'm going to be showing you a little bit about my data analytics program that I have here that does some Minecraft seed cracking. This one in particular is finding um, four Minecraft desert pyramids based off of recent data. But before I even can get into any of those technical details, I'm going to give a little bit of a elevator pitch about what Minecraft seed cracking even is. So, with this whole idea, this basis around that within the game of Minecraft, generation is based off of math, and nothing is truly random or unique when you use a computer program to attempt to draw randomly generate or create things. Meaning, with enough time, brains, and effort, all of these mathematical equations, all of these random number generators, all of these formulas that were used can be reversed. We can take the data that they output and we can backtrack them back to where they began. So what that's being used in this sense is to take the generational world seed of a Minecraft world. Like that is what you can put into your world, and no matter how many times you put it in, like you're always gonna get an identical world to that seed. Like if you put in the seed 1, 2, 3, it is always gonna look the same. I mean, granted that does change depending on the version you are on, but like that's not the point. So because of this, we can do some really cool stuff, and I'm gonna be talking about that now. So let's get into it. Right. Right. So what this program I have here to show off is it finds four desert pyramids based off of these all pause positions. All pause being a variable that means region position, which we are going to explain shortly. And I have this in as a data set, which then I find all possible world seeds that would fit these four things of data. Originally, my hope and goal was to be able to develop a program far enough to be able to completely reverse a Minecraft world seed, and I thought I was super close and stuff. But then I started documenting, found some bugs, which were then fixed, and then it was one thing after another, and I'm gonna need more time, and it's gonna be finished later, so like that's gonna be exciting. But what this is this is a much simpler program, but like it's still quite confusing. It's like it's definitely weird if you don't know anything about Minecraft or just code or Java. Like it's realistically probably not that complex, but it's just I think the Minecraft aspect of it that really makes it as nerdy and confusing as it might seem. So let's just go through each thing of the code. Actually, first, what I should show you is that it does work. So, I already had it running, but you see, if I just click go, I just start cramming out seeds. Like you see, one seed after another. Like it's just a whole bunch, and all of these seeds have one thing in common, and that they have a desert temple or desert pyramid, as they want us to refer to as, but I have it defined as pyramid, within the region position of 0, 0, 0, 1, 1, 0, 1, 1. So we could take any of these. We could put this into this application here called line map, and you see. So in the grid can kind of show us the regions, and we see 1, 2, 3, 4. They kind of fall apart, but there is really we have a really big desert here, so there's a whole bunch more desert pyramids, but those aren't technically being accounted for in the data. Like, we can take this one from down here, and we can exit that out. We can put this here, we can flow this up, and settings, show grid. Then we have 1, 2, 3, 4. So what this is not actually Minecraft. Minecraft is a three-dimensional game, but it is a tool using the exact same libraries that I am using here, so like it works well together. Which kind of this gives you this 2D map feel of a Minecraft world. Like, it's super cool. I can go around, see off the biomes, see how stuff generates. I can zoom out like that to see a lot of cool stuff on how stuff. Actually, it's super cool. I don't have the performance on my computer right now. I'm looking at my processor. It's like spiking high with this recording and running the program in the background. But what's really cool about Minecraft generation is if I were to be able to zoom out far enough, you start to notice that it starts to repeat itself, because like I was talking about before, nothing in computers is truly random. Like, it just starts to repeat itself, and it's just the same generation algorithm. But like, that's just a cool thing just to nerd out about and find interesting. It's not technically super relevant to the showcase of this video. So one thing I really want to show you when starting to understand like a region position is I want to show you what this is called as structure seed mode. So what this shows is a whole bunch more structures. So like, what are we actually seeing here? So like, we see like a boat here in the middle of the desert. We have an ocean monument, but you see tends to be only one of a type of structure per region. You see, we only have one ocean monument per thing. We only have one. Actually, woodland mansions are way more spread out. You don't see them as often, but we have a lot of X's and things. What's going on here? So these are all the possible structures, and it is theoretical and mathematical, like early on within like the structure generation, for there to be a buried treasure there. But later on, generation determines that this is actually going to turn out to be a desert, and the generation of a buried treasure, although being able to spawn in any chunk of the world, and the game has determined that this is a chunk that it could spawn in, it can only generate within beaches. So realistically, it looks more like this, and it's not as cluttered. So what's really interesting, especially about this, is like it's only like one structure per this region, and the region really fluctuates on what it is. But for a desert pyramid and a jungle temple and a swamp hut, and really most structures, it's a distance of 32 chunks. And a chunk is like how Minecraft generates every single bit of its world. Like, it doesn't generate it technically block by block. When you are loading in new parts of the world, when you're running that algorithm to make new parts of the world, you are loading in these things right here, and this is basically just a bit of land that's going from all the way from the bottom of the world way up to the new height of 320. So it's this 16 by 16 bit of land. That makes sense. So that gives a little bit of context. So what I'm doing here is I'm assigning that I want to find a region position 0, 0, 0, 1, 1, 0, 1, 1 of a desert pyramid, and then I want to get that spacing. So getting that spacing, I explained this before, but in this thing, if I wasn't doing a disappear mid, was to say I was doing a buried treasure, they would have a different reason size. Like it wouldn't be 32 chunks, so that spacing would just do it. But what's unfortunate about this, and the reason I am now multiplying this by 16, is this finds it as a block position. So like a block position is like the exact coordinates of a block in the world. And although like that is it's still useful for what I am going to be doing within this code, it is not useful because it takes longer. Because really what you have to consider is there was a lot of possible Minecraft worlds and outcomes. And like actually, in fact, there is 18 quintillion just possible Minecraft worlds. I don't know if you've seen my presentation already and know that fact, but that is mathematically impossible to brute force every single possible seed. So we just need to, we want to like search the littlest parts of the seed as possible. Like we don't want to be doing and taking time that we don't really need to. In this program, it doesn't really matter because I'm not pinpointing much of a thing because I'm more finding. But when I get into the practice of cracking, that's what's going to be super important. So coming down here, I start getting into more of the code of the program. So I have this this new definition that I start to use throughout the program, a new chunk rand. So basically that is just a randomizer for the world to like generate this the basic surface terrain, and actually it even generates bedrock patterns, which this random cool useless fact. Every single Minecraft world, despite having this unique, cool, fancy generation, has the exact same bedrock pattern, which is actually a useful strat for using Minecraft seed cracking because you can find the coordinates of things quite easily. But that is way too beyond of the scope of this thing, and we're getting distracted. So now, like we talked about, what we really want to find is if we search all 18 quintillion possible world seeds, that even with this program, that would take quite a while. We don't need to do that. It is not best practice. So the Minecraft world seed is 18 quintillion because it's 64 bits. So that is like 64 yes or no questions, like of like 64 like things. So that's like 2 to the power of 64 because like there's two options, like yes or no, a 1 or a 0, and like there was just so many different combinations they can have that with that. It is like technically if you like put 18 quintillion seconds, that is like longer than the existence of the universe, so it's a big number. But 48, 2 to the power of 48 is a lot, quite a bit small, all things considered. It is handleable. Like we can handle that. We can deal with that. So what that is actually referred to is a structure seed. So what I'm doing here is I am finding anything. So I'm shifting. I'm taking. Wait. Let's see. What am I doing here? Sorry. Right. So I'm shifting 1 by 48, which is this equivalent to 2 to the power of 48 bits. Pretty simple, but it's complicated. Not really. Sorry. Now, what we are setting up to do in this next part of the code is for taking our region positions into chunk positions. We have already explained what region and chunk positions are. They're like referred to within this code as CPOS and AllPOS. But we can use the chunk data of like about these desert temples to do more within the code, but we'll see that closer to when we get there. So we're making a new list right here. Then we have this cool thing right here. It's a cool thing from the library, get in reads in. So what I can basically do is I can get new CPOS data. I'm calling it pyramid reads in, and I'm taking pyramid, so I'm taking the pyramid I've defined right here. Actually, you see it's highlighted, and I'm saying get in reads in. But what that requires me to do is it requires me to give a structure seed, and then a reads in X and a reads in Z, as well as a chunk random. And luckily, I have all of that defined. Like I have get X, and you see get X would pull for X data from here, 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 and get Z would pull the Z from here, 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 and here. Chunk random, like that would just take our randomizer that we just defined here. I didn't name it something fancy up there. My naming's quite boring sometimes, but you know what it is. it's like I could have named it something super funny, and I now like regret that I didn't do that. But yeah, actually, I didn't even mention that I did this, but like it's a cool, super cool thing that I can do is I can do Control B, and that opens up the library thing, so I can just see about it on how it works. And you see for this one to use the CPOS get in reads in, so taking reads in data to get a chunk position, that requires you to have a structure seed, a reads in X and a reads in Z, as well as a chunk random, which is pretty cool. I hope that makes sense. But yeah, now we check if our pyramid reads in that we just defined up here is if it's null. So like that is meaning like that is completely nothingness. So like null is like this in motion sense is like an equivalent to like 0. But if it's not null, like if it's not like invalid, we add it to our we add it to our list that we will come back to later. And then we're gonna skip that for now because that's a little surprise for later. Now we have those that structure seed. Structure seed is referred to as our lower 48 bits because it's actually referred to that because the same reason that like it's in structure mode right here, because that lower 40 bits of information within that 64-bit world seed is being used to randomize and assign all of these structures. So that's pretty cool. But 48 is not enough. We need 64 bits of information, meaning we have 16 bits remaining, meaning we need to find all upper bits. So we can take so world seed equals, because we want to find a world seed, structure seed to world seed. So if what we see what that does is it shifts over our structure seed by 40 sorry, just tired. So we're defining world seed, and then with the help of dot world seed, we are shifting over by 48 bits and putting the structures at the bottom. So yeah, what we're doing is we are shifting this structure seed over. So with the structure seed that we have defined up there over, and then we are adding this upper 16 bits to the front, which would give, well, 16 plus 48, 64, if that makes sense. We then do one last biome source because this is like the same thing of equivalent of what is happening right here. So you see, if we go into like structure seed mode, because it's not aware of the biome that it's in, this jungle template can spawn. But when we do this biome source, we know that can't spawn there. So like we're kind of doing a very similar thing when we end up doing this biome source. Right? So we're doing a biome source of an overworld dimension. Like what's super cool is I can define all of the dimensions. I can do end dimension. I can do nether, but I'm doing overworld. The version that we have defined as 1.17, and then our world state that we just found. So then we have a new boot lane, or boot. I said boot lane. I'm not changing that. I say boot lane. Yeah. So can spawn it both is equal to true. So basically what that does is if it checks if it can spawn at both. So if so when that is true, and when the pyramid can spawn at the chunk position, so with the chunk position with really with this, scratch that. Okay, so what this down here beyond under the biome source does is we have the can spawn thing that we have set up with the boot lane, but we'll explain that shortly. But what this can spawn function does is it's super simple. It's basically this scene if our pyramid can spawn, and what that requires to work is that requires a chunk position of somewhere in the world and a biome source. And the biome source is pretty self-explanatory of what it does. How it works is kind of confusing, and that goes into noise maps and biome generation, which is not technically needed to fully understand to be able to use these libraries, which is super cool. But I need both of that to be able to obviously figure out if this pyramid can spawn there. Then if it can spawn at both of these locations, I system out, print a world seed, and then I'm good. And this down here allows me to run it. So, whoa, it works. But, let's actually run that again. One thing you might notice about all of this is, despite like this working technically, I am finding, let's see, 1, 2, 3, 4 desert temples within a 4x4 grid of each other. You see, like, I actually never got to explaining that, but I'll explain that later, I guess. What is really happening is it's just what really sucks is that they're really far apart. So what I can do is I can add one more bit of code that I have. Let's see, it's right here, and what this does, I'm just gonna bring it back in. Oh, I mean that is, so this is doing a distance metric. So let's just go in and see what that does. There's no good explanation on that. Yikes. So in a nutshell of what this is doing, so after bringing this back in a nutshell, what this is doing is this is taking our Z within our CPOS that we determined, and it is discarding anything that is greater than 13 chunks. So if it is not less than, if it is greater than 13 chunks, it is discarded. So it has to be equal to, it has to be less than 13 chunks, or about 13 chunks, to be, like, for us to be able to continue with this code. So that makes them a lot closer together. So you see, if we run this again, and if I take this seed instead, and then if I do settings, show grid, we can see that these desert tempos, like especially these two right here, are a lot closer together. Yeah.